Okay guys, so these are the notes for the angle of depression. This is on the back side of your notes page from last class. So the angle of depression is when you see an object below you and there's an angle of depression between the horizontal line and your line of sight to the object. The horizontal line part is very important. So here what I have is a lovely stick figure standing on top of a cliff, and they are looking down at the boat. And so you want to look at the horizontal line, and it's the amount that their head has to turn to look downwards. So people always label this one wrong. So it always has to be touching the horizontal line and what you're looking downwards at. Here's an easy example without the picture part to it. So elevation is horizontal looking up. Depression is horizontal looking down. So our first example problem has to do with David. David, who is 6 feet tall, is on top of a local business. He looks down with the angle of depression of 63 degrees or 73 degrees to see his car, which is parked 34 feet from the front of the building. How tall is the building that David is standing on? So we want to label everything. We have David is 6 feet tall. So I know from here to here is 6 feet. Label that as 6 feet. And then he looks down with an angle of depression of 73 degrees to his car. So here is my horizontal line, and we want to show him looking downward to his car. So that is going to be right here for my 73 degrees, which is parked 34 feet from the front of the building. So here's my front of the building, and here is 34 feet. Okay, so we have our 34 feet from the front of the building. How tall is the building that David is standing on? So we want to know how tall is over here. So the top of the building down to here to the ground. That is what we are searching for. So I have my X labeled right there. Now, here's the thing that makes the angle of depression an ounce more tricky, is that our degrees is over here. So my triangle is going to go on this side of the problem right here. So what I have is I've got the person is 6 feet tall and they're standing on top of the building. So this X, I'm going to carry it over here. So this side is going to be 6 plus X. And then this 34 degrees, I'm going to carry it up to the top. That's 34. So I can redraw my triangle just to kind of show you it a little bit in simplified terms what exactly we're looking at. So we're looking at 6 plus X over here. We have 73 degrees. We've got 34, oops, there we go, 34 right there. So this is just a little bit easier version of what I have going on up there. We want to know how tall that building is. And so this part is X. And then this part is 6. That's to account for how tall David is, who's looking down on the building. So we are going to label this O, A, and H. We've got opposite over here, adjacent over here, and nothing for hypotenuse. So this is going to be a O over A for 73 degrees. There we go. Now, I'm going to go ahead and fill in the right side, which is this part right here. So my O is 6 plus X, and my A is going to be the 34 degrees. And then for the other part, I'm going to come over here to my trig table, and I'm going to go over to 73 degrees, and I'm going to look at my O over A value. So that's going to be this last column over here. So at 73 degrees, this is O over H, this is A over H, and this is O over A. So I'm going to record this number right over here. So that number is 3.4874. Make sure I get this right. I'm sorry, it is 3.2709. 3.2709. Always make sure that you get the correct number. And then we always put a 1 underneath it. So now I can cross multiply and divide. So let's get our calculator. And I'm going to go ahead and multiply those two. So 3.2709 times by 34. I get 111.2106 equals, and then I'm going to multiply these two together, so that's just 1 times this is just going to stay the same. So now what's going to happen here is I'm going to have to subtract 6, and so I get x equals, and I'm going to leave this in my calculator, just hit -6, so it'll take the answer from above and subtract 6. So this 105 is going to be the actual height of the building. So the 111 is the height of the building plus the height of David, who's 6 feet tall. So then when I subtract out David's height, this is going to give me just the height of the actual building minus David's height. So we're going to come over here, and you need to write over here some sort of sentence for your answer. So anytime you have a word problem, you need a word answer. Okay, so I have the building is 105.2016 feet tall. That's as much as you need for a sentence. Okay, so now I want you to, you're going to pause the video and you're going to go ahead and do this one on your own. That says Krista is 5.5 feet tall and is on top of a 60-foot tower, preparing to ride the zip line to the ground. Looking downwards, the end of the zip line, her angle of depression is 32 degrees. How long is the zip line that Krista will ride? So go ahead, pause the video, and try this one on your own. So if you're struggling right now, here's how you should have it set up. We have Krista, who is 5.5 feet tall. We have the 60-foot tower that she's standing on top of. And then the angle of depression is 32 degrees. And it says, how long is the zip line that they will ride? So we are wanting to know this value right here. So again, if you're stuck, try closing in your triangle right now and go ahead and solve this on your own. Okay, so let's talk about what I have right here. My hypotenuse is the missing length, so I label it as an X, that's the zip line. My opposite side, now this is important, so you should have 65.5. What I've done here is I've taken the height of the person, so this right here is 5.5 feet, and then the height of the tower from here down is the 60 feet of the tower. So 60 plus the 5.5 of the person, when I put these two together, that gives me 65.5 feet for my opposite. So my triangle O over H, opposite over hypotenuse, right here. And then I got this number from my table, 32 degrees for O over H is 0.5299. Always put that over 1. Cross multiply and then divide. I did have to round on this. Okay, so I had to round a little bit. And then this is my final answer. So the zip line is about, because I had to round, I have to use the word about 123.608 feet long.